Hello and welcome to week 7. I hope you're doing well today. Now in this video I will cover a few topics. I will cover how we work with files in Python. Then I'll move on to semi-advanced features when using functions. Then I'll talk about pseudocode. And I will also go over this week's assignment, which is challenge 2. Alright, so one of the biggest advantages of using Python is its ease and simplicity in handling files. And the typical operations that we can do on any file is known as CRUD, which stands for create, read, update, and delete. So this means we can create a file, we can read a file, we can update a file, and we can also delete a file. Now to start working with a file, we use the Python built-in function called open. This is the key function for working with files in Python. And as you can see here, it takes 2 arguments. The first argument is the file's name, which would also include the full path to the file's location. And the second argument is the access mode, which means are we going to access this file to read from it, or are we going to create the file, or are we going to update the file, and so on. And last but not least, you can see that note at the bottom, which basically says when we open a file, we get back a file object. So we don't get back the data in that file yet. Now to get that data, we need to read from the file after we open it. So again, opening a file only returns a file object, and from that file object we can then read or write the file's data as we wish. And here are the different access modes that we can use when we open a file. The R is for read, so it opens the file for reading. Now this is the default value, so you technically don't need to specify the R if you know you're opening the file only for reading purposes. But one thing you need to watch out for is that the file you're reading needs to exist with the same name you specified in the open function, and within the path you specified in the open function as well. So if the file doesn't exist, it will throw a traceback error that the file does not exist. Now the second access mode is the letter A, and it stands for append. So an open function with the A argument means we're opening the file to add data to it. And in contrast to the access mode R, if you open a file with the A mode and the file does not exist, it will not error out, but it will instead create the file for you. So please be aware of this difference. With the A access mode, if the file doesn't exist, it will create it for us. But with the R access mode, if the file doesn't exist, it will error out. The next access mode is the letter W. Now this is similar to the A access mode in that it writes data to the file, and if the file doesn't exist, it will create it for us instead of erroring out. However, the big difference between the appending and writing access modes is that writing simply writes over the existing data. So if you have 100 lines in your file and you use the W for the access mode, it will erase all those existing 100 lines and replace them with the new data. So please be careful with the access mode option you go with. And the last access mode option we have is the X access mode. Now X means we want to create the file in the open function, and so it only creates it without doing anything to it. So no reading or writing to it. Now if you run this command and the file already exists, it will error out. So in general, it makes sense to always check if the file exists before doing these operations, especially the R and the X access modes, since these will error out if the file doesn't exist or if the file already exists. And in addition to these access modes, you can also specify what type of file you're working with. And there are 2 kinds. It's either going to be a text file or anything else, which is binary. So to note this file type, we use the T letter for text files and a B letter for binary files. And binary files could be images, for example. And as you can see from the bottom line, this is how we specify it in the code. Now, text is already the default value, so you really don't need to specify it. And so based on that piece of information, if a file is being opened for read-only and it's a text file, then since both reading and text are the default options for the access mode argument, then you technically don't need to specify them at all, and just use the file name as the only argument for the open function. Now, once we have a file object, we get access to some more methods. Some of the common methods are read, readLine, readLines, and there's also write and writelines. We will see these in action in just a moment. But quickly, the read method returns the content of the entire file. The readLine method returns only one line from the file. The readLines, which is plural of readLine, returns a list of lines from the file. And then we have the write method, which writes a specific string to the file, while writeLines writes a list of strings to the file. Again, we will see these methods in action in just a moment. Finally, when you're done working with your file, it's part of best practices to close the file object. This will allow for two things. Number one is that sometimes data is not read or written from or to the file if the file object is not closed. And the second reason why it's good to close a file object is to free up any used resources. For example, for Python to open a file, it will use up memory space, which is a resource. And if you're done with a file and you don't close it, Python will keep these resources tied up for a while. Now, there's a built-in functionality in Python called garbage collection, as well as in most programming languages really. And their job is to clean up any such open connections by closing them. And so we free up used resources. So technically, you don't need to run the close command because this built-in function of garbage collection will close it for us. But still, it's best that we do it ourselves as it's part of best programming practices. Now, having said all that about the open and close methods when working with files, there's also another quicker and more efficient option. We can use the with keyword before the open method. So the exact syntax would be as you see here. What this will do is exactly the same thing as we have seen with a regular open function. But the added bonus is that we don't need to call the close method on the file object when we're done. Why? Well, because the with approach does that for us automatically. So it's like the garbage collection, but quicker as it happens right away. And this way, we also get to type less code, but get more functionality. Alright, so I'm going to go through some code examples to demonstrate using the open function and working with files in Python. So this is a sample code, and up here I basically have the open function, and as an argument I'm just passing the file name. Now I'm passing just the file name and not the full path because this file physically exists in the same location as this code file as well. If it does not, then I have to specify the full path that leads up to this file here. And to show you this demo file.txt file, here it is. It's just 4-liner. This is a demo text file. We have some text here. Testing this in Python. Thank you and goodbye. Okay, so just some simple text on 4 lines. Now, what this line of code is going to do is it's going to call the open function, pass the name of the file, and then it's going to open it and assign it to a object called FO, which is a file object. FO is just a variable name. I called it FO, which is short for file object. You can call anything you want. And then down here, once I'm done working with my file, I call the close method just to make sure that once the file is opened, I don't want to tie up any resources, so I'm going to close the file object using the name of the variable dot the close method. Okay, so if I run this code, nothing really happens because all I did is I just said open that file and close it. All right, so let's start reading from the file, but first I wanted to show you this line of code as well. Now this line of code is exactly the same line as this. The reason being is I'm now using access modes, and we learned that the R means read and the T means text. So I want to open this file in read mode, and this file type is a text file. But we learned moments ago that the read access mode is a default access mode, and the T, which is short for text, is also the default type. So again, if I comment this out and I run this code again, I don't get any errors, and the file has been opened and then closed right away. Okay, now let me see what happens if I call a file that doesn't exist. So I know this file doesn't exist. All right, I'm going to open a file called badname.txt. Let's see what happens. Okay, I get an error and it says no such file or directory, bad name text, which makes sense because this file does not exist. All right, let's comment that out. Let's bring the first method back, which is read. So the read function basically is going to read whatever is in the, oh, actually, I'm going to bring this back as well. All right, so I'm going to open this file File is going to be open. I'm going to assign it to a file object. Then I'm going to call the read method from this file object. Okay, so this is going to read whatever's in this file, and we said that this file has this information. So let's confirm that this is what's going to be returned. Alright, so open the file, read the file, close the file object. Alright, let's run it. That's exactly what we get. We get the full file. Alright, so the read method reads the entire file. Now what happens if I don't want to read the entire file? Let's say I want to read just a few characters. Well, we can take this out, bring this in. So the read method, when you don't pass any arguments, is going to read the entire file. But within the argument section, we can pass a number that's going to pass the number of characters that you want to bring back from this file. So if I run this, I get back, this is A. Alright, so let's count it actually. 1, 2, 3, 4, 5. Spaces are counted as characters. 6, 7, 8, 9, and then here's 10, which is a space. So what this line of code did is that it read just the first 10 characters of my file. Alright, so read with no arguments is going to read the entire file. Read with a number is going to read those numbers of characters back. Okay, now what happens if I want to read a line, not just number of characters? Well, we can do that as well. The read line method allows us to do just that. Okay, so I'm going to open the file, I'm going to call the read line method, then I'm going to close it. So let's see what this returns. Okay, it returns the very first line. Okay, now we also have read lines. Read lines is another method that you can read not just one line, but let's see exactly what it returns. Run it. It returns all our lines one by one, but in a list format. So now that we have a list of our lines, we can loop through it, we can count it, we can do anything we want to do having a list. Okay, for example, let me comment this out. When we have a list, we know we can count how many items are in a list using the len method. So if I uncomment this, this is the same exact code as what's up here. Okay, I'm just going to call the len method or the len function and pass this as an argument so that I can get the count of this list, because now this we know returns a list. This here returns a list, and then I'm going to pass that as an argument to the len function, and that's going to return to me how many items are in my list, which would tell me how many lines are in the file. So if I run this, I get 4, which is correct. 1, 2, 3, 4, because in my list I have 1, 2, 3, 4 elements in my list. And we also talked about the with open. So let me comment this out again. Now we don't need the close method anymore, and I don't need this as well for now, and I'm going to uncomment both these lines. So now everything is commented out except for these two lines here. So this basically says with open demo file text as FO colon indent, don't forget the indent, then print whatever gets read back from the read method of the FO object. Okay, so this is a little bit of a different formatting than this, but the nice thing here is that instead of having a close method, this is going to open the file, it's going to run the function, whatever you want to do with that file, and it's going to close it for us once it's done. I don't need to call a close method or a close function explicitly anymore. So let's run this. And we get the file again as expected, and the file has been closed. It's in the background, we can't see it, but it has been closed automatically without having to call the close function anymore. So that's the key difference between using the plain open function versus the with open function. Okay. Now the second example I wanted to show you is this code here. Now this is going to walk us through the append function as well as the write function. And the file I'm going to be using here is called demofileappend.txt. So let's take a look at what that file includes. Alright, it's just a one-liner, sample content for appending. Okay, let's see what the code does. Now from here moving forward, I'm always going to be using the with open because again it's the more streamlined version of using the open function. So with open, and then I'm going to give it a file that I'm going to work with. For the access mode, I'm going to use A, and we said A means append. Okay, So with open this file in append mode as FO, which is again is going to be my assigned file object, what am I going to do with it? Well, I'm going to write to that file, and this is what I'm going to write. Okay, now the /n basically means new line, and this is the text that I want to append to my file. So again, this is what the file has right now, and let's see what happens when we run this. And instead of opening the file and looking at it this way, I'm going to read the file using code. So up here, I'm opening the file in access mode, and then I'm going to write to it. Then, once that change has been done, I'm going to open the file again, but this time in read mode, and then call the read method of the file object so that I can see what this file currently has. Okay, I hope this makes sense now, but we'll see it in action. So again, open the file, append this data, and then read the file and display this data. So let's run this code. Alright, so we know that we had sample content for appending already in our file, and now we added a new line with this text in it, and when we ran the open function on the new file after it's been appended, we now see the 2 lines instead of the 1 line. Okay, so that was the append function. Now let me comment this out, and let me uncomment this one in. Okay, so now I'm going to go through the write function mode. So I'm going to open a file. Again, the name of the file is demo file writing. So let's see what this file is. Okay, so it's a one-liner as well. It says here is a file with some text that will be erased soon. Let's go back to our code. Alright, so we're going to open this demo file writing.txt file. The access mode is going to be W, which is for writing. And then I'm going to call the write method, and I'm going to write this text. Okay, whoops, I did it again and erase the content. Okay, now once we've made this change, then I want to read the file again, the same file that I made the change to, in read mode, and display all the text that's in that file to see if this got erased, which it should, and then it got replaced with this. So let's run this code. And there you go. I no longer see that line. That line has been erased because I'm using the W access mode. And it's been replaced with, whoops, I did it again, and erase the content. And to verify it, if I close the file, this one, and open it again, there we go. And the last piece of code I wanted to go over is creating a file. So we know that W is going to write to a text if it exists, but if it doesn't exist, then it's going to create the file for us. So here I'm basically using the input function. I'm going to prompt the user to please give me a name of a file, and then I'm going to assign it to a variable called user input. Then I'm going to call the traditional with open. I'm going to give the file name, which I don't know what it is, but it's going to be the value of whatever the user typed in. And I'm going to call it with the W access mode, and then I'm going to write, here is the text to add to the file. Okay, now once I've created the file and added text to it, then I'm going to come down here and again open the same file, this time in write mode again, but the file already exists and already has this text in it, correct? But now what I'm going to do is I'm going to, since I'm doing a W, which is write, and we learned that W will erase whatever is in the existing file, and then append or add to it this new line of text. Okay, so W here, the file doesn't exist yet, so it's going to create it, and then it's going to add this line to it. Then I'm going to again call the same file with the W access mode, and then write some more lines to it, which means that this line is going to erase whatever was in the file, which is just this one line here. Then I'm going to do an append on the open function. So append doesn't erase, it just adds to it. So I'm going to add a new line, and I started the text with a /n so I can get a new line after this first line, so it doesn't continue on the same line, but it's going to do a carriage return. So it's going to add a new line called append one line, and then I'm going to add another open function with a access A for append, and this time I'm going to pass not just one line like I did here, but I'm going to pass a list of lines. So I have first line, and then I'm going to have second line, I'm going to have third line. Okay, and again, remember the /n is always a new carriage return or a new line. and all that's going to be saved to a variable called lines, which now is a list because square brackets and then multiple items. And then I'm going to write lines, which is one of the methods. Instead of calling one line at a time or writing one line at a time, I now can write multiple lines at once. Okay, so again, to recap, I'm going to create a new file, whatever the user types in, using the W access mode. And then I'm going to call the same file again, also the W access mode, but this time it's going to erase whatever is here and add this to it. Then I'm going to append one line, then I'm going to append a list of lines. So let's run this and see what we get. Alright, please give me a file name, so I'm going to say testing file.txt. I'm going to hit enter. Okay, nothing comes back, alright, but let's go ahead and open this testing file and see what we get. Okay, and here we go. We get the adding first line. I no longer see this text here because this was originally there, but then it got overwritten with another W. But I do see adding first line, append one line, first line, second line, third line, which I see here. Adding first line, append one line, first line, second line, third line. Okay, so I hope now you feel a little bit more comfortable seeing some examples of how we could work with files in Python. Alright, so in a previous video, we talked about the basics of functions. And in this video, I wanted to discuss some more advanced topics. Okay, now just a quick recap in using arguments with functions. We can have positional arguments and we can have keyword arguments. The positional arguments will depend on the position location or the order of the argument, while the keyword arguments will not care about the order or the location of the argument. Instead, it will use the key equals value syntax. However, both these type arguments require that you know the number of arguments needed for the function. But what happens if you don't know? I mean, what happens if you want to build a function that can take a variable number of arguments? And that's where the star args and star kwargs come into play. So in Python, star args and star kwargs are special syntax used in function definitions to allow a function to accept a variable number of arguments. Now, these notations are commonly used when you want to create more flexible and generic functions that can handle different numbers of arguments. So star args allows you to pass a variable number of non-keyword arguments to a function, and it collects these arguments into a tuple. And here's a simple code example. In this example, the addNumbers function can take any number of arguments, and it adds them together using a loop. So I create a function called addNumbers, and in the parameter area, I type star args. This indicates that I can accept a varying number of arguments. Then I have indented code in the body of the function which runs a few statements to loop through the arguments and adds them to each other. And so in my first function call, I call the addNumbers function, and it passes 5 arguments, which are the integers 1 through 5. So this function call demonstrates that this function can accept 5 arguments. Then I have another function call, but this time I only pass it 2 arguments, the numbers 10 and 20. So now the addNumbers function will still work fine because I'm using the star args notation. And by the way, I don't have to use the word args in particular. So I could have used star followed by any word I want. And I'll show you this when I go through my code examples later. But it has become customary to name the variable arguments as star args. Now, we also learned before that there are 2 types of function arguments. One is positional and one is keyword. Positional is when the position of the argument matters, while in keyword argument, we specify the value of the argument when we pass it. And the previous slide showed us the variable positional arguments. And now this slide shows the variable keyword arguments, which uses the star kwargs notation. So this star kwargs allows you to pass a variable number of keyword arguments, like key value pairs, to a function, and it collects these arguments into a dictionary. In this example, the printPersonInfo function can accept any number of keyword arguments, and it prints them as a key value pair. So when I call this function, I pass it 3 key value pairs. Name is equal to Alice, age is equal to 30, and city is equal to Wonderland. And when I run this, I get a loop of the key values from this dictionary. I could also have passed any number of key value pairs, and the function would still have processed them successfully. Now, you can also use *args and *kwargs together in a function definition, but keep in mind that *args must appear before *kwargs. So we can mix and match them, but for this to work, you must organize the *args first before the *kwargs. Now in this example, we start off with arg1 and arg2, which are just regular positional arguments. Then we have *args, which collects additional position arguments of an unknown count. Then we have kwarg1, which is a default keyword argument. And finally we have *kwargs, which collects extra keyword arguments, also of an unknown number of items. Now in the function call, I have arguments with values 1, 2, 3, 4, kwarg equals custom, name equals Alice, and age equals 30. This means that arguments 1 and 2 will go to the parameters arg1 and arg2, then arguments 3 and 4 will be used by *args, then argument kwarg1 equals to custom will be for the parameter kwarg1, but instead of having the default value, it will have custom. Then the rest of the kwarg arguments, like name equals Alice and age equals 30, will be used by the *kwargs parameter. So as you can see, using *args and *kwargs can make your functions more flexible and versatile, allowing you to handle a wide range of input arguments. Alright, let's take a look at a few examples here. So here I have a function definition called test1, and in the parameters section it takes a *args. So that means, based on what we learned, that it can take a variable number of arguments to this function. And then it's going to print whatever those arguments that got passed. Okay? Down here I have the function call using the same name, and I'm going to pass it one argument and a second argument. Okay, so let's run this and see what happens. I get back a tuple of my list of arguments that I passed. Now what happens if I want to make more arguments passed? Will it still work or fail? Now, let's say third arg and fourth arg. Alright, let's run this again, and I still get back a tuple of 4 arguments. So this demonstrates that the *args works as expected, which means it can handle a variable number of arguments. Now I mentioned already that we don't have to use the word args. We can technically call anything. So I can say anything, and then just make sure that you modify the argument name. So *anything, print anything. So let's just, for demo purposes, let's make this 5th arg. Alright, let's run it, and it still works. Alright, so again, you can use *args or any word. Just make sure that you are consistent. But it's been best practices to always use args as the variable argument name. Okay, let's comment this out now. Let's move on to the next one. Alright, so here is basically another example of defining a function using *args. I'm going to create a variable called results that equal to 0, and then I'm going to loop through using a num iteration variable in args, which is this guy here, and all I'm going to do is I'm going to just keep adding the numbers to each other and then return the result. So this is an example of having a function that can sometimes pass, you know, 1 or 2 or 3 items. In this case it's 3 items, and the function is going to handle it correctly, looping through item by item, adding it together, and then returning the result. So this function call uses 3 arguments. This same function call uses only 2. Okay, and then they get assigned to different variables. And then I'm going to print them out. Sum1 is whatever value of sum1 is, and sum2 is going to be whatever value of sum2 is. So let's confirm that. And there we go. It worked fine without an error. sum1 is 6 and sum2 is 30, which is correct. 1 plus 2 plus 3 is 6, and 10 plus 20 is 30. Okay, let's get rid of this for now. Let's bring in kwargs. So kwargs, again, works the same concept as args, but this time we use key value pairs. So again, the same exact function as up here, but this one uses kwargs, which is key value pairs instead of just arguments. So instead of positional arguments, I'm going to use keyword arguments. So for test1 function call, I'm going to pass my first key, which is first, and the value is Michael. Second key is second, and the value is b dot. And the third key value is third, and the value is Jordan. So if I run this, now notice instead of getting a tuple, tuples are identified with a parentheses, I get back a dictionary, which is expected. So the positional arguments in args, in star args, returns items in a tuple, but with star kwargs, it returns back a dictionary because of the braces with key value pairs separated by commas. All right, and again, just to test it, let's say here's a fourth key, and I'm going to set it equal to, let's just say junior. Okay, and let's run this again. Okay, so whatever I add to it, it's going to keep accepting it and running it successfully without any errors. Okay. All right, and the last example I wanted to show you is down here. This is where we could mix both the args and the kwargs. Okay, so here I have a function called example function. It has one positional argument, a second positional argument, and then a variable number of arguments, followed by a keyword argument. Here is the key is called kwarg1, and then the value is default. So this is going to be, if I don't pass a kwarg value with a pair here, key value pair here, then it's going to take a value of default. Okay, and we'll see that in just a moment. And then I'm going to follow it with an unknown number of keyword arguments as well. And all that this function is going to do is it's just going to print everything out. It's going to print the arg1, whatever it is. It's going to print arg2, whatever it is, and so on and so on and so on and so on. Okay. In my function call, I'm calling the function, and I'm passing 1 as an argument for arg1. I'm going to pass 2 as an argument for arg2, and then for the star args, which I don't know how many they could be, I'm passing 3 and 4. Then you can see here I'm not passing any kwarg1, so that means kwarg is going to get the default value because it's not passed here in the function call. And then for the star kwargs, again, I don't know how many they are, but based on this, I have 3. Name is going to be Alice, age is going to be 30, and city is going to be Wonderland. Okay, and again, all this is going to be printed here. So let's run this and check it out. Okay, so I'll move this to the right. So arg1 is arg1, which is 1, which is 1. Arg2 is 2. Arg3, which again is a star args, is going to be a tuple of all the values, which are 3 and 4. kwarg, which was not in the function call, but it was defaulted here, so then it's going to be default. And then kwargs, which is the star kwargs, is going to give me a dictionary of all the items that I have here. Okay, now if I come down here and I say kwarg1 equal to custom, for example, then this value is not going to be applied because I overrode it with this value here. So let's run this and confirm it. There we go, kwarg1 now is custom. Now I mentioned before, if I'm mixing and matching args and kwargs, that means args have to come first, followed by kwargs. So here I have my args followed by my kwargs. Okay, now what happens if I move this kwarg guy? Let's cut it and let's paste it here. Okay, so I have kwarg followed by args followed by kwargs. Let's run this and see what happens. Alright, there we go. I get an error saying that positional argument follows keyword argument. Okay, so we can't have keyword in the beginning and then positional argument follows. Alright, so just make sure that when you're mixing and matching args and kwargs, that you always use the argument first, followed by kworks. And it runs happily again. Okay, so I hope these examples were helpful in shedding some light on the arguments and keyword arguments in functions. Alright, so I wanted to discuss pseudocode with you. Now, pseudocode is a crucial tool in application design and development. Basically, pseudocode is a high-level description of the code that you want to eventually write, which blends natural language with programming-like words and symbols. And the beauty of pseudocode lies in its flexibility because it's not tied to any specific programming language. Its primary purpose is to help us plan and describe code before we jump into actual coding. Now, before I became a programmer working full-time at a company, I would just sit down, code an idea that came to me. So I programmed on the whim without much planning. And as you might have guessed, I made a lot of mistakes. I had to recode stuff, and I wasted time doing all that just because I didn't plan my code out right. It's always wise to plan your work first, then execute it. And this is not particular to programming, but in all walks of life. So for pseudocode, let me make it simpler for you. Imagine you want to write a cool application, but you just don't know how to use difficult computer words. In other words, you want to explain your thoughts in plain English instead of actual syntax code. That's where pseudocode comes in. It's like making a plan using simple, everyday words and following some special rules. So let's say you want to use the computer to help you make a peanut butter and jelly sandwich. In pseudocode, you might write something like this. If there is bread, and there is peanut butter, and there is jelly, then take 2 slices of bread, spread the peanut butter on one slice, spread jelly on the other slice, put the slices together, and if. So you're basically telling the computer, hey, if we have all the stuff, let's make a sandwich. And you use words like if, then, and if to make it super clear what you're doing. These words are not mandatory to use, but they're just regular English words that make sense to use in this case to describe your logic. So pseudocode helps us plan what we want the computer to do without worrying about the exact computer language it understands. It's like writing down our ideas before we start building something. So pseudocode is like our secret language to talk to computers in a way they can understand, even if it's not in computer words. So pretty cool, right? Now let's look at some basic elements of pseudocode. I did explain that we can use our own simple regular English words when writing our pseudocode, and like anything, there are some standards to guide us and help us make pseudocode consistent for all of us. So here we have some basic constructs when creating our pseudocode. And the goal is to make our pseudocode clear and concise. One group of constructs involves when we have a sequence of actions, like capturing an input from a user, then outputting something back. Also at times, we need to compute values, as well as initialize values. And we usually find the need to increment and decrement values. So these are all found under the sequence group, and in dark blue, we have the actual words used in our pseudocode. Again, you don't have to use these exact words, but they are here as a guide. Then we have other constructs. For example, if you need a loop logic, we have a for loop, we have a while loop, and we have a repeat until loop as well. And we already saw an example of using conditionals with the PB and J sandwich example. So we saw how easy it was to use if-else statements. And we also see in the lower middle an example of the case scenario. Now we also have here additional constructs to call functions and to handle errors as well. These again are very common practices in programming, and so we see how to call a function by its name and parameters. We also have an example of how to call a function and return a value. So again, just plain English words. And these examples use the word call, but again, you don't have to stick to this particular word. For example, I could have replaced call with run, or replace it with the word execute. Remember, pseudocode is not syntax, so we can use any words to describe our thoughts. So as you can imagine, non-technical people can write pseudocode, hand it over to a programmer who then can interpret the pseudocode into real syntax code. As for the exception handling, these are the guided words to use. We start with begin, then run some logic, and if an error occurs, we go to the exception block. And inside the exception block, we can specify the specific type of error, just like in the real syntax code, but we use simple words. So I said that pseudocode is flexible and we can use any words, but still we have some standards that would be nice to follow. Nothing will break if you don't follow these standards, but they're just best practices to guide us. For example, you might have noticed that all the command words were written in capital letters. So here they are again. All these words are in caps. And to help make the pseudocode clear and easier to read, use only one statement per line. Also, do use indents to organize your statements. Again, this is not a must, but it helps to improve readability. And when you are done with a certain logic block, it's best to use the word end to signify that you are done with this part of your pseudocode. And remember, pseudocode is language agnostic, so when you write your words, keep it as that, language independent. You don't need to use particular words or style of coding that might be suitable for Python or Java or any language. And for point 6, it basically suggests writing your pseudocode to describe the problem or your goal instead of how you will implement it. So the example here shows the pseudocode of append the last name to the first name, instead of writing a variable name that is assigned a value of first plus last. If I write the name equals first plus last, that would be pretty close to syntax. The goal with pseudocode is to always keep it in plain, simple, concise, and readable language. Alright, let's move on to this week's assignment. You will be building or improving a chatbot using Python. You can either extend the program you worked on in previous weeks or start something completely new. If you will start from scratch, there's a list of ideas provided at the bottom if you need inspiration. And please do your work in VS Code to create a .py file for your chatbot. Make sure to use these skills we've covered over the past few weeks, like use variables, functions, conditionals, user input, loops, and dictionaries to manage your code. Now your code should be clean and broken down into functions that do one specific thing, and please don't forget to add comments to explain what's going on. And as you build your code, please test your chatbot with different inputs to make sure it doesn't crash or act weird. Then, once you're happy with how your chatbot works, you'll write a short explanation, somewhere around 200 words, about what your chatbot does, how your code works, and how you tested it. And if you used any external help like Google or ChatGPT, you'll need to mention how and why you used it. Now my suggestion for this assignment is to please have fun with it. And please make sure to submit both your chatbot.py file and a Word document that contains your write-up, all by the due date, which is this coming Sunday. Alright, now if you have any questions or comments, please reach out via email or through the Canvas inbox. You can also post your questions in the Q&A forum. Just please remember that the forum is a public area and is read by the entire class. Okay? So thanks for watching, and I'll see you in class. Take care, and bye for now.